Alright guys, my name is Andrew Magra.
I'm Andres Bayo.
I'm Audrey Muller.
And I'm Siddhant Samad.
Together, we are Group 3, and we are here to present you guys our new product, Pinball. So, a couple weeks ago, or rather, a couple months ago, I was going down to an arcade with a group of my friends, and being that we're poor college students, we didn't have that much money on us. And we saw these pinball machines, and we were thinking, man, I really want to play some pinball. But we didn't have enough money between all of us for everyone to get a game in. And this was kind of disappointing because pinball's a fun game. So I went home mildly, displeased from my arcade experience, and I was thinking, how can I make this better? So as a group, we came up with a solution to this problem, and we call it Twinball. And what this is two-person, head-to-head pinball. So as you can see right here, we have our nice render in Creo of our Twinball game. All of these parts were modeled in Creo and designed for assembly using a 3D printer and a laser cutter. This is our first assembly of the prototype. As you can see, we have features such as paddles, ball launchers, and an automated obstacle mechanism in the center. Now I'm going to pass it off to my partner, and he is going to explain some of the key features of Pinball.
Alright, so how do you play? Basically, it's like regular pinball. You first engage the switch to turn on the toy, which will start moving all the mechanisms and also power the components. You load the ball into one of the two launching mechanisms on the side. This launches the ball into the middle of the playing field. Then the first player to score 3 points on the opposing team wins.
So what's the play value of our toy? Well, first of all, our little obstacles we have here come in and out. We didn't glue them in because one of the things we like about this is that if you own this and you are into 3D printing, you can print your own obstacles for it if you want to do some design on your own. Or you can just take them all out, have a clean field to play on, stretch rubber bands around them, do whatever you want. It's very designable for the person who owns it. Also, the transparent chassis is really nice because you can see everything on the inside. You can learn how this is a Scotch Yoke mechanism. You can see how that all works. It inspires some educational creativity. You can see how our mechanisms work, everything like that. And then also, one of the things is that the ball we designed so when it rolls off, it's just going to roll automatically into the launcher. So you don't have to be taking the ball, putting it into the launcher. Like if you're playing foosball, you have to take it out and drop it into the funnel. For ours, it just automatically falls right in, like if you're playing regular pinball, and the launcher works so that when you pull it back and release it, it's going to launch up and into the center of the field so it can fall to either side. Now I'm passing it off to Sid to discuss some of the unique attributes.
So the first and the most important unique feature that we're proud of is the modular aspect of the game. So like Audrey mentioned, you can take off the pegs, you can rearrange them as you like. You can make your own obstacles, you can use rubber bands to rearrange it, and just use your creativity, and that way you're playing a different game every time and it never gets old. Another key feature is the LED scorekeeping for ease of score, and as you can see, it's placed right next to the knob for your convenience because, as Audrey mentioned earlier, the ball automatically rolls into the launcher and you can just shoot it off, so the game can get quite fast-paced, so you don't have to worry about finding the button for the LEDs. You can just hit it as you're playing. The also the Scotch Yoke mechanism, which we will demonstrate later. But essentially, we have moving obstacles and to keep the game interesting. Yes, and then we have the launcher mechanism, which gives you a fair chance because as you can see, once you launch the ball with this mechanism, it ends up right in the middle of the game. And as it hits one of the obstacles on this Scotch Yoke mechanism, it can end up on any end of the field, and you have a 50-50 chance. And the last unique attribute is the transparent body. So you can look through, you can see the different mechanisms, you can see how they work, and inspire future engineers. So hopefully they make even more fun toys. Right. features is the launcher mechanism. So this allows the ball to be placed right in the middle without any bias, and as mentioned, it would hit one of the obstacles on the Scotch Yoke mechanism. That way, the ball will end up on either side of the field, giving both players a fair chance. We have rubber bands that provide the necessary force for the launcher. So if you want to replace something, the rubber bands, it's easy to take apart and put back together. You can also use different balls if you like, and just adjust the rubber bands for the force required for that ball. We have hollow cylinders to get the ball to its desired position, which is the middle of the field. And the ball was launched, as mentioned, right in the middle. So both it's right in the middle and it's a better chance, basically. And Andrew will talk about the mechanical feature.
Thank you, Sid. So, in order to make our game more dynamic and exciting, we wanted to have moving obstacles in the center of the field that you have to attempt to navigate the ball around. So, the biggest problem with this was trying to figure out how to transfer rotational motion from a cheap motor into linear motion for the obstacles. And we decided to do this using a Scotch yoke mechanism. So the way this works is you have a driver circle that has sort of like an indent coming off the end of the circle that hooks into a little smiley face almost shaft. And as you can see, as that driver circle rotates, the little nub that is inside of that hollow bit of the shaft pushes the shaft up and then brings the shaft back down. For any of you taking 444, and I believe this is the same mechanism used in assignment number 3. Now, in order to have more than one obstacle, we paired about 6 of these Scotch yoke mechanisms together through bearings and metal shaft to keep it relatively friction-free. We offset all of these Scotch yokes by about 180 degrees, so when you're playing, you'll always have a gap to shoot for because only half of the ghosts should be up at a time. We designed a dead band into the bottom of the yoke, so when the ghosts are down at the bottom, they'll stay at the bottom longer than they'll stay at the top, which gives you a better chance of getting the ball over. Now, Andres is going to talk about the hitters on his side.
Now, for the pinball arm mechanisms, basically what we wanted was a mechanism that translated the linear manual input from the user into the rotational output of the arms. This allowed the user to hit the ball with the desired amount of force, whether it be to overcome the slant of the playing field or just keep the ball on their side to further think of the action that they can take or the strategies that they can take to win against the opposing side. Now, the available range of motion that we have with the arms was restricted or designed to interface with the chassis and the knob. Therefore, we only have a certain amount of motion that it can go through and output a certain amount of force. It also resets to its initial position using rubber bands. And to get the smooth motion and general feel of a pinball machine, we used some linear and rotational bearings that had that were designed for in the 3D printed components to be fitted with just simply tolerance fit. Now, so what is the market potential of our product? Well, basically, pinball machines are ubiquitous in arcades. So people love pinball machines, especially myself. Our machine also provides a new platform for these machines in general, shifting the focus to a more social and interactive experience rather than an individual one. Our modular design also allows for the game to never get old. Basically, you can just change the game depending on the level of difficulty that you want to play in and any other playing preferences. We also believe that our design has good scalability in terms of having one of these machines at an arcade or also selling the product for home use of casual arcade gamers. So what is the future of the product or the future of our design if we had an iterative design? Well, basically, first of all, what we want is we want to add more complexity without any convolution or decreasing the visual integrity of our product, of our design, both in terms of aesthetics and use. We also want to include a wider variety of obstacles. We've mentioned that users can design and make their own obstacles, but we also want to give these users certain obstacles that come with our design. We also want to increase the rigidity and quality of the materials that we use. We came to some problems when manufacturing this, especially in terms of like transportation, it being very fragile. And we want to improve also the manufacturability of our design without compromising or sacrificing the modifiability that we included with a modular obstacle. So thank you very much for your time. Are there any questions?
Before we take questions, we'd like to show you guys a live demonstration on how Twinball works. So, would you like to play? All right. Just going to rotate this over here. All right, so we're only going to use one ball right now. So the first thing you do is turn on your scorekeeping and obstacle mechanism. And let's go. Oh, there we go. I scored a point. I'll press my LED. One of the green LEDs will turn on, indicating I have scored a point. And if you were playing a real game, you would keep playing until one person scored 3. All right, now we will take some questions. All right, in the back.
What's the purpose of the engine here?
All right, so the question was, what's the purpose of the motor or engine? The purpose is just to keep the game fun and exciting by having like moving obstacles. Lots of real pinball machines have sort of like moving targets you have to try to hit with the ball. We wanted to imitate that with actual motion.
Could you rotate it so we can see?
Oh yeah, no problem, no problem.
You turn it on for a second. No, 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 like turn the switch.
Turn the switch on so
With it facing down. Unfortunately, the shaft broke, so only 3 of them moved.
Yeah. All right, yes, right there.
So now, are there any concerns about hitting the ball too hard and it flying off one side like the ramp?
The question was if there's any concerns about hitting the ball too hard and it flying off the machine. And yeah, actually we did have that concern, and we designed covers to put on top of this so the ball simply would not fly off the ramp. Unfortunately, when we were manufacturing, we accidentally made the covers a little bit too small, so they don't really fit on very well, so we just decided to ditch them. However, in our course of playing, we played a couple of test games, and we have yet to have the ball fly off the side, so it's looking pretty good right now. All right, well, if there's no other questions, we thank you for your time.
Thank you.